Do you often find yourself out of energy, feel weak, and are experiencing joint pain? Well, you might be diagnosed with hemochromatosis type 4, also known as ferroportin disease. Hemochromatosis type 4 has two subtypes, A and B. Type 4A involves a loss-of-function mutation where ferroportin mutants are unable to transfer iron out of cells, which is seen with low transferrin saturation levels. Type 4B involves a gain-of-function mutation where mutants are resistant to hepcidin, which inhibits ferroportin activity, thus results in trouble with downregulation. Hemochromatosis is a rare autosomal dominant disease where one affected allele is enough to be affected. It affects less than 1 in a million individuals. This disease involves the buildup of iron in the body. It is caused by a missense mutation in the SLC40A1 gene, where arginine is converted to glutamine. The SLC40A1 gene is responsible for controlling the function of ferroportin. Ferroportin absorbs the iron received from food in the small intestine and transports iron out of immune cells that also store iron.
Symptoms of hemochromatosis include weakness and lethargy, weight loss, joint pain, usually in the second and middle fingers, abdominal pains, liver dysfunction, impotence and low sex drive, menstrual disorders such as early menopause, loss of body hair, and skin darkening. If you or a loved one are experiencing any of the symptoms, then we have the solution for you: CRISPR. CRISPR is a simple yet incredibly powerful tool for editing genomes. With CRISPR technology, our company will be able to help you with all your blood-related needs. CRISPR technology can alter genetic material at specific locations in the genome. What does this mean for you? This means that we can take that pesky mutation and turn that glutamine in your body back into an arginine just like normal. You'll be back to your energetic self in no time. CRISPR is also faster, cheaper, more accurate, and more efficient than other types of gene therapy on the market. CRISPR, or CRISPR-Cas9, was initially adapted from a naturally occurring genome editing system in bacteria. But don't be alarmed, this isn't the big, scary bacteria that much of society tries to rid itself of. This is good bacteria that was able to provide us with the footprint for our technology.
A small piece of RNA with a short guide sequence is created which binds to a specific target sequence of DNA in a genome. The RNA also binds to the Cas9 enzyme. The modified RNA recognizes the DNA sequence and the Cas9 enzyme cuts the DNA at the targeted location. Once the DNA is cut, researchers use the cell's own DNA repair machinery to add or delete pieces of genetic material or to make changes to the DNA by replacing an existing segment with a customized DNA sequence. Since hemochromatosis involves a missense mutation, arginine to glutamine, CRISPR could be used by using the modified RNA to recognize the target sequence and allow Cas9 to cut at the targeted location. This procedure can be performed by removing cells from affected individuals, editing the DNA, and then injecting the cells back into the person. This treatment will allow affected individuals to be free of this disease as well as other complications that could have been acquired due to iron buildup, including liver damage, diabetes, arthritis, and heart problems. You can also return to eating your favorite iron-rich foods, including meat, spinach, fish, and whole grain pasta.
Like with any new science, there are ethical concerns associated with this great technology. Some concerns include the future moving toward designer babies, where desired traits can be chosen. Think about when you order food at McDonald's. You go up to the kiosk and order what you want. Imagine doing the same for your child. picking and choosing traits that you want your kid to have. Another concern is germline gene editing, which means editing the genome causes changes in heritable genes. This refers to edits made not in their somatic cells but in the gametes, which can be passed on to their offspring. Lastly, informed consent is questionable, as researchers cannot truly obtain informed consent as the long-term risks are unknown. This technology affects our society in many ways, both good and bad. Some pros include improving agricultural livestock and crops. Gene editing can help produce higher yields of crops as well as increasing nutrition and making them more endurable to extreme weather. I mean, who wouldn't want an apple that doesn't brown after it's cut? Developing new antimicrobials. Antibiotic resistance is a growing concern. CRISPR can be used to edit out these antibiotic-resistant genes, making them sensitive to these antibiotics. And attempting to control disease. An example of this is seen in labs where they are introducing deleterious genes into malaria-carrying mosquitoes. The cons include the effect of off-target, which can cause unintended genetic modifications and result in genomic instability. Another disadvantage is mosaicism, where some cells will carry the edit and others won't. And lastly, accessibility is debatable. Will genome editing only be accessible to the wealthy and create discrepancies in the healthcare system? And will classes of individuals form based on their quality of the edited genome? These questions are something we need to consider.
Our company strongly believes that the advantages of using CRISPR technology to help with your hemochromatosis outweigh the disadvantages by a landslide. This product will help you get back to the life you deserve without the stress of blood and genetics on your mind. The ethical barriers outlined will be controlled for while you're living life the way you've always wanted.
This new therapy will be seen on posters in doctors' offices and on public transportation, as well as between shows on multiple TV channels. If you know of someone with this disease, send this video to them or share it on your social media so everyone can know about this new treatment.